These are the capacitors, also known as condenser in the market, and they are connected in series and parallel to increase its capacitance or to decrease in capacitance. Today we will study about the parallel combination of capacitors. First of all, the first wire of the first capacitor is joined at a point, and second capacitor is also joined at a point, and wire of third capacitor is also joined at a point. All first wires of capacitors are connected at a point, and another wires, second wires, are connected in the second point. This combination is known as the parallel combination of the capacitor. You can see this is the combination of parallel plate capacitor. You can plug the both wires in the circuit. This is the parallel combination. But the question is, what is equivalent capacitance in the parallel combination of capacitor? Let us draw figure. This is the first capacitor, this is the second capacitor, this is the third capacitors. The first plate of all capacitors are connected to a point, and second plate of all capacitor is connected to second point. The plus q charge is given to first point, and second point is earthed. The capacitance of first capacitor is C1, second capacitor is C2, third capacitor is C3, and the charge distribution in the capacitors are Q1, Q2, Q3. This charge distributed according to their capacity. The potential difference across all the capacitors is V. Let us see the wording of the figure. There are three capacitors C1, C2, C3, and first plate of all capacitors connected to a point, and second plate of all capacitors connected to second point. Plus q is given to first point, and second point is earthed. The all capacitors have same potential difference V, but different charge distribution, that is Q1, Q2, Q3 respectively. We know that C equal to Q upon V, capacitance equal to charge upon potential difference. Now charge equal to Q equal to CV. For first capacitor, the charge gained by first capacitor is Q1 equal to C1V. V is same for all capacitors, and C1 and the charge received by this capacitor is Q1. For Q2, that is C2V, and Q3 equal to C3V. These are the charge distribution in each capacitor. Then total charge is Q equal to Q1 plus Q2 plus Q3. Putting these values here, Q equal to CV, this is CV, Q1 equal to C1V, C1V, plus Q2 equal to C2V, plus Q3 equal to C3V. Now take common from these, V C1 plus C2 plus C3. V and V are cancel out, then C equal to C1 plus C2 plus C3. This is the equivalent capacitance in parallel combination of capacitor. Then equivalent capacitance is equal to the sum of individual capacitance of capacitor. Here the points are: the potential difference is same for all capacitors. Charge is distributed among the capacitors according to their capacity, and this combination is used to gain high capacitance. For high capacitance, capacitors are connected in parallel. Thank you.